Hey, welcome back on my channel. Very happy to have you back. Let's start straight away that video with a question. So, in 2023, as an interviewer, do you think it's lame to still ask for design patterns during an interview? Let me know in the comments and I will give you my answer as well. Okay, so today the prototype design pattern. So it's a creational design pattern like builder pattern or singleton pattern to create objects. So it's really nice to help you to decouple when you want to copy an object, so you won't rely on the struct or you have loose dependency on it. Okay, so first we will have a code example, so in Go obviously. So I'll show you how to implement that design pattern as usual. Then pros and cons, I like to have a little debate, so let me know what you think as well, if you disagree or if you agree. And then I started doing that since the previous video, so you will have a link to the GitHub with the code, so then you can have a look yourself. But as always, I'll really encourage you just to type yourself, discover by yourself, make mistakes and learn. But you have the code if you need. Alright, and last but not least, before I let you with your learning, so like and subscribe the video if obviously you enjoy this kind of content, so it helped to get some visibility of this kind of content, and it's also helped me to understand that you enjoy this type of videos, so then I can make more. So yeah, happy coding everyone, hope you enjoyed that one, and see you later. Okay, so here we have a directory with a main function and a Go mod. So here I just created a subfolder called publisher and a file within called publisher.go. So we will implement a publisher and try to implement the prototype design pattern on the top of it. So here I'm declaring an interface called iPublisher, I for interface, and we will simply define one single method called publish with a message string. Alright, so here I just reorganize my layout. So on the left you have the main function and on the right the publisher. So on the main, I want to make sure that I'm invoking an interface and not an implementation. So then we can see later that things are properly decoupled and we are not relying on implementation. So if we simply start little, so let's just print a message basically. So you can see that run function needs to take an interface publisher and a message as a string. So if we invoke that, so we need a publisher. So at the moment we only have the interface, so let's just implement the struct. So you can just call it my publisher or default publisher. ID shortcut, so we will implement iPublisher. So it's doing the heavy lifting for me. It can be a simple struct method, and as I said, we can just log that message. Alright, so now if we instantiate a publisher in the main program, so we can call it publisher for instance, and then it's simply a struct, and then passing that publisher to the run function with hello for instance. And then if we run that, we should see hello. So let's try that. Okay, so there you can see hello on the line, so we can just modify the layout because otherwise everything is gonna be vertical, so we can have the terminal at the bottom. Okay, just to make sure that it's working as intended, if I swap hello with goodbye and run again, you can see goodbye. So All good. So simply a function relying on interface, and we have implementation of that interface. So far so good. Okay, so let's make things a little bit more interesting to have a reason to apply the prototype design pattern. So here I'm enhancing my implementation with a field called ID, which is a string, and you will notice that it's a private field. So from my main program, I do not have access to that. And even worse, I'm creating a constructor function here, which I'm not gonna allow the main program to pass that ID. Instead, the ID will be a random UUID. So UUID is like those kind of long string with letters and numbers. You will see an example in a bit. So, and here I'm enhancing the message that we log with the publisher ID. So that will be crucial for the next part of the pattern. So here I'm just chaining chunks of string there. So I'll run it so it will make sense for you in a bit. So here I just need to update, because UUID is just the Google package, so I just need to add it to the Go mod. So nothing really dramatic there. So you can see it's adding it to the Go mod. Okay, so if we run that again, we should see the message. My computer is a little bit slow, so let's rerun again. Alright, it's compiling. Alright, so then you can see publisher space arrow goodbye. So ID is just empty at the moment because we haven't invoked our publisher. So you can see my ID is telling me that's not used because that function is in gray, line 17 on the right. So here, instead of brutally instantiating the struct, we will invoke the constructor. And if we run that program again, so there you can see that's a UUID basically. Okay, so we have now the ID of the publisher publishing. So the problem now, where the prototype pattern applies, is if I want a copy of that publisher, because maybe that ID is like a security token and I need to copy it, or assuming I'm allowed to copy it. So I wouldn't be able to do that now because it's a private field. So you can see if I'm instantiating another publisher, you can see that it's given another ID. So I won't be able to, for instance, verify the authenticity in that case. So here I'm just defining another interface called the iPrototype interface, and it simply has one method called clone, and you can see line 14, I'm doing an interface composition. So my iPublisher needs to have iPrototype. And you can see on the left that my IDE is complaining because my publisher and publisher 2 are not implementing those interface anymore. So here I just simply clicked on my IDE and it implemented that interface for me. So very convenient. Okay, so clone. So this is the core of that pattern. So essentially we want to make a copy of the publisher. So here I'm amending slightly the interface of that clone prototype method. So I need to return obviously a clone. So in order to be reusable, I will just render an interface. So here you can see that I'm returning my publisher, and I just changed the return type, and you can see that it's valid because my publisher is an interface, any. Okay, so let's try that clone function then. So if publisher 2 is just a clone of the publisher 1. Let's try that. So you can see now my ID got copied because of line 24 on the right. So you can see that I have now the same internals, essentially. So that's it. That's the very 101 of the prototype design pattern. Okay, let's make things a little bit more interesting now. So let's add another field into that publisher. Okay, so here it's the opportunity for me to show you a text library, native library from Golang itself. So it's not an external dependencies cases. All right, so with our full message on line 36, we want to uppercase the whole message. But what's good with the cases library, you can send a language tag. Not every language will uppercase a string in the same manner. So let me just show you. So we will make as a parameter first. So you can see we're defining a case, an upper with language as an option, and then you can send your string, and we will log that. So here I'm just parameterize it the constructor. So language is now able to be instantiated from the constructor. So like that, and you can see that on the left it's missing the language, and also I need to change my clone method, otherwise the language won't be copied if you want to clone one of the publisher. So that's one of the downside of the prototype pattern. You still have to manage the clone process. And then as language we can say language English. So I'll show you. So for instance, goodbye and hello, it will be full uppercase as with no I need to just declare, even though it's internal library, I need to declare it. That's fine. So I just clicked on the ID helper, and then I'll rerun that. So you can see that it does put everything in uppercase. So good. But in some other language, like when you have like accent or dots on letters, it does not uppercase the same way. So you can see in English, I leave, it's like I leave like uppercase, you might know, but if I put Turkish, for instance, they do keep the dot on capital I, like that. So you can see I leave with those dots. So that library is really good when you're working on internationalization, when you want to make apps with different language and you just have a config. So it handles it really cleanly. Okay, so all of that to show you that the cloning, how you do when you have to extend a field with the prototype method. So you can see here I had to extend the clone method. That's fine. Okay, so with that pattern, you will often see a prototypes registry. So I'll show you how to implement it in Golang. So first thing first, I need to refactor slightly because I declared that I prototype interface with the publisher package, which makes no sense at all. So I just created a subfolder called prototype, and we will move that interface in a file there. So the package name will be prototype, and the file can be also prototype. So here I'm just using the full capacity of my IDE, so you can see it does it without complaining, and you can see it prepended with the correct package and all good. So solid. All right, so quick refactoring. So let's create that registry. So we will define it as a struct called registry. It will hold like a data store for those prototypes. So the simplest data store in code, in inline code, is a map. So let's define a map with string as key and prototypes as values. So very simple. We'll create constructor for that, but we will not let the user pass a data store. So we will initiate an empty data store. By data store, I'm just talking about a map, by the way. It's big words for simple objects. So with that registry, the first method will be adding a prototype. So or receive a method here called add, simply add. So you want to pass the key, which is a string, how you will reference that prototype, and obviously a prototype. I named the package prototype, which is not really smart because now I can't really use the name prototype as variable, but that's fine, call it proto. So here, just like line 16, just inserting something in a map, very simple, and then declaring the second method, we'll simply just call it get. So with get, you pass an ID and you get back a prototype or an error, because maybe you messed up the key and it won't be found, or other kind of errors. So if you remember, the way you query on a map is just like angle bracket, and then you get an object and a boolean. So if the boolean is false, it means that it hasn't found it, so we can just simply send back an error, not found. And if it did found it, we can just return the object. Yeah, classic, very classic Go pattern with that tuple, prototype, and error. So here you can see a simple implementation of a prototypes registry. So let's try it. So registry, then prototype, probably will invoke that new registry constructor. There you go. So we have a registry, an empty registry. Let's just register our Turkish publisher. So as ID, we can call it ter and then publisher. Okay, so I will move line 15 and have a copy of that publisher, so we make sure everything works as intended. I can put 2 in the message to differentiate it, and then let's call it copy, the copy of the publisher. So we will receive an error, a prototype and an error. So registry dot get, we need to get it with the ID that we put, like TUR, and then we can invoke with our run function from the beginning, we can invoke that copy. So here it's complaining, it's because copy is like a keyword, so let's just rename it as, yeah, Turkish publisher is probably a better name. Okay, so you can see here the red squiggly, so it's because it's missing the publish method. It's not a publisher because your registry gives you back an I prototype, not an I publisher. But that's fine, I can cast it to an I publisher. There you go. I could have cast it as my publisher, but it's stronger to cast it as the interface because your run function takes an interface. And then the second squiggly was on the error because it was unused, but here if it's not nil, we can just print it. Obviously you would have to handle it much better than that in real life code, but yeah, that's good enough. So you can see it works as intended. It did register it. So when we retrieved it with the ID, it gave us back our publisher. You can tell by the ID, it hasn't been altered, so it's really good. So here I just want to show you the error. We haven't any prototype called eng, so you can see that it hasn't been found, eng for English. And that's it. This is our prototypes registry. Alright, so let's discuss pros and cons now. So it's obviously my own opinions and arguments. So if you disagree, if you agree, if you have other pros, other cons, let me know in the comment. I'm happy to discuss. That's really good. Let's start with pros first. So you can see that patterns is useful when you want to copy objects where it's and you don't want to couple it with other services which would take it and not having access to internals. And it's really nice in Go because you can see it's using interfaces at full capacities, like interface composition and relying on interface, so it's really clean. So that's a really nice pattern. Second, it does reduce boilerplates because you could see that I could clone as I wanted those publishers, so it does save you some time, and it can also be done at runtime, obviously, because you can invoke that clone method on runtime if certain conditions are met, or if you're receiving some parameters from your application and you need to clone on demand. It's really good. And then a little bit of a repetition, but it does increase reusability because obviously I declared a publisher the mechanism of how to publish once, and then I can just create objects with parameters and reuse them as I want. So it's kind of a cool pattern in that sense. Alright, so now the cons. So I briefly mentioned it while I was adding the new field language to the publisher. So you still have somehow to have to clone manually, as in ID of the old publisher that you want to clone into the ID of the new clone, and that for each field. And it might be complicated because in the example I did, it was just a string and an ID or a language tag, but it might be structs of structs or some other complex entities that you might not be aware of. So be really careful with that. Sorry, a little bit of repetition here. It's that design pattern is questionable for very complex structs, basically. So maybe your struct is not well built, or do you need this kind of complexity in your struct? So be really careful with that. And lastly, obviously, if you are dealing with pointers, be really careful when you clone, because you might copy a pointer, and then if you change if you want to manipulate a clone, but your clone is holding a reference from the original, you might end up with really tricky situation, with really tricky mutations. So keep it simple. Make good usage of that pattern for simple cases, and yeah, be aware of those pitfalls, basically. Alright, finally, as promised at the beginning of the video, here is the link for the GitHub where you will find all the code I just showed you, so then you can have them as reference. Alright, so I hope you learned something today for the beginners, and if you're a veteran, I hope it was a nice refresher for you. If you have any questions, if you disagree, if you want to argument with me, or if you want to shout at me, feel free to leave a comment and I'll do my best to reply to you. And as said to you, see you next week and happy coding. Bye!